Welcome everyone. This is an IAQM Early Career Network event, Navigating Odour Assessment. This webinar has been organized by our Early Careers subcommittee, and to kick things off, we will be hearing from our chair, Odour Pucciato.
Thank you, David. Hello, everyone. So my name is Anna Pucciato. I am chair of the Early Career Network, and me and David, we both at the main committee for IAQM. And I would like to welcome all of you at this yet another webinar that will extend our knowledge about the air quality, about different areas of air quality. And I'm really pleased to see that we had so many sign-ups for this webinar. Odour is not something that we deal in our work very often. So it's great to hear that we can actually show to you some case studies from our great speakers from Early Career Networks. We will hear also from Lawrence, who developed guidance as a part of the initiative from IAQM. So I think it will be really interesting and great to see you all. At the same time, I would like to advertise this Early Career Network forum for everyone who would like to practice and share the case studies, the work they're doing. Please always hand up, just respond to our calling, but also let us know if you've got something interesting to say and to share. This forum is for you to practice those presentation skills. It's for you to share the knowledge and also help others to develop. As you know, we also publish our newsletter. So if you feel like you would like to add a case study or some vlog or have something to say about air quality, please get back to us. Okay, without further ado, I will pass to David, who will introduce you to our first speaker. Thank you.
Right, thank you, Odour. First, we are going to hear from 3 members of our Early Careers Network, and a massive thanks for them to come forward and present to the in this webinar. We will provide some other assessment case studies, after which we'll hear about the IAQM recent work on update their other guidance. As always, we will have there will be a chance for questions at the end of all the presentation. So please do submit these in the Q&A option at the bottom of your screen at any point during the presentation. I will then ask this on your behalf after the first 3 presentations, and then about the guidance update will be another session for questions specifically on that guidance. If your question is for a specific person, please put the name in the question box, so we'll help. First up, we will hear from Alicia Scarpa, from environmental scientist. She's an environmental scientist at Warder Armstrong, and she's going to talk about the qualitative odour assessment techniques and the public inquiry process. Over to you, Alicia.
That's great. And hi everyone, thanks for having me. My name is Alicia Scarpa. I'm an air quality consultant at Warder Armstrong, and I've worked here now just over 1.5 years. And in that time, I have been growing a portfolio in odour work. From odour observation surveys to building evidence for the inquiry process. Now, a lot of this evidence that I prepare for inquiries focuses on people's perceptions of odour, which I think is interesting because odour is, as we know, quite subjective. However, it's my goal during this process to transform this subjective data into a data set that acknowledges concerns from members of local communities and creates an objective, usable data set that can be analysed, reviewed, and when necessary, critiqued. In this presentation, I'll show you what I think is a very interesting example of where this has been done. But before I do, I know that many consultants watching now will know the face people make when you tell them what you do for a living. usually of confusion, disbelief, and a little bit of intrigue. And it often turns into a conversation on the subjectivity of odor. We'll have conversations about their friend who likes the smell of petrol. They'll tell me the smell of horse manure reminds them of their childhood. Some will even argue over odors we often have a positive association with. For example, a friend was telling me over the weekend that he can't stand the smell of banana. But of course, it's subjective. And because of the perception, this is because the perception of odor is partially innate. We possess an extremely important ability to recognize certain odors to avoid danger, such as foul-smelling bacteria that causes food poisoning, or to recognize smoke from a fire so we can seek safety, but also to do things like to seek food. But it's also important to note that the perception of odor is also partly determined through life experiences, and hence it can be subjective to the individual. For example, I lived above a sandwich shop where every morning I would wake up to the smell of freshly baked bread. And it sounds lovely, doesn't it? Well, you know how people can hear the sound of an alarm and instantly feel on edge? Well, the smell of bread after a few months every single morning did the same to me. I detested it and it knocked me a little sick. But this is where we need to differentiate between an annoyance where the adverse effect, so feeling sick after smelling bread, occurs from immediate exposure, versus a nuisance caused by the repeated events of annoyance, so feeling sick after smelling bread every single morning before a 9 a.m. lecture. And some of you will hear me complaining about the smell of freshly baked bread and kindly say, come on, Alicia, get on with it. And this is because in general, there is an agreement as to what is and what isn't a pleasant odor. I'm sure many of you will agree that bread smells better than cow manure, but there's still a wide variation between individuals as to when odors are acceptable, and importantly, when odors affect an individual's quality of life. So yes, odor is subjective, but because there are some generalizations that can be made, such as what constitutes an unpleasant odor, guidance can be built on top of this to estimate the significance of potential odor effects. And this is what the current IAQM odor guidance does, providing a method for estimating the significance of potential odor effects for odor assessments that support planning applications. But what about operators of sites subject to environmental permitting, such as waste treatment sites? Well, odor guidance for these operators and their advisors is presented in the H4 Odor Management Guidance issued by the Environmental Agency. But just for the sake of keeping this presentation to 15 minutes, I'm just going to focus on the IAQM guidance, which gives us a plethora of ways to estimate the significance of potential odor. Now, the IAQM arms us with many predictive tools. Overarching these are quantitative assessments, which includes dispersion modeling. And this is often used to estimate the impact of odorous emissions on local areas. It's often used for source emissions that are identifiable, measurable, and they aren't subject to large variation. And there's also qualitative assessments, which focuses on a risk-based tools using the source pathway receptor concept. And I'll be discussing around this concept throughout this presentation. Now, these type of assessments incorporate multiple secondary tools. We have conventional monitoring approaches such as sniff tests, looking at meteorological conditions, chemical compound analysis, or even using the field olfactometry, which uses this hilarious looking device below. We can also use a community assessment approach. This includes things like odor diaries, attitude surveys, and of course, complaint data. But what's important to remember is that the IAQM guidance advises that when drawing conclusions of the overall effect of a given odor source, the results of the assessment tools together should be given considerable weight. So here I want to introduce an interesting project for a client who submitted a planning application for the construction of 175 residential dwellings on an allocated site within the local plan. And that sounds great, but approximately 800 meters is a composting facility where they've got concerns about odour. Now, the work undertaken as part of the original planning application failed to provide sufficient information to fully assess the impacts of odour upon the living conditions of future residents. We were instructed after this refusal as the client decided to appeal the refusal decision. And I do have to mention now that we had no part in the original planning application. Now, composting facilities are actually great examples of odour sources that are very difficult to model. They accept organic waste such as food and manure, and they turn it into compost. It's arguably a key component in reducing the amount of waste going to landfill. Now, this particular facility carries out windrow composting, one of the most commonly used industrial composting techniques. As you can see in this picture, organic waste is positioned into these long rows that can reach 8 feet high, and this particular structure allows for heat and aeration to break down the organic matter. Although it's effective at breaking down organic matter, this process can make composting facilities such as this one very difficult to model. This is because it's a fugitive or an uncontrolled source of odour. Rather than the controlled release of odour through a stack, for example, the odour escapes into the atmosphere, making sampling to determine the odour emission rates very difficult. And the windrow method requires the turning of these rows in order to ensure that organic matter breaks down evenly. And these pictures are not of the Sutton Courtenay site, but it shows the windrows turning both indoors and outdoors. And this turning creates spikes in odour emissions from the piles. However, when left undisturbed, they're much less odorous. So in other words, the odour emissions rate is subject to large variations. Now, because of the nature of the composting site, i.e. the odour emission rates can't be reliably determined, and because this is subject to large variations, we determined the best course of action would be a qualitative assessment, which incorporates sniff tests, prevailing Met conditions, and also an analysis on the extensive odour complaint data. We proposed this to the local AHO, and they were happy with the proposed approach. So let's dive a little deeper into the odour observations, or the sniff tests, if you will. So previously, no sniff tests were undertaken by Wardell Armstrong due to the Met conditions. Basically, the wind was blowing the wrong way and the proposed development site wasn't downwind. However, we did eventually get the right conditions almost. We had warm temperatures above 20 degrees and there were calm winds. And these conditions were representative of conditions when previous odour complaints had been high. But the wind was still blowing in the wrong direction, and the proposed site was still upwind. So we selected locations along the proposed development to the west of the composting site to get an idea of what odour would be like during upwind conditions. We then also selected sites to the east of the composting facility to represent odour conditions directly downwind. Now, of course, odour was detected. At one location, the odour was described as rotten, waste, and eggy. And odour from the facility was detectable up to approximately 1.06 kilometres away. At this distance, the odour detected was classed as very weak to strong, but was detected for very short periods of time. This is because the odour will have been heavily diluted and dispersed before reaching this location. So in accordance with the IAQM guidance, this corresponded to a negligible to slight adverse odour impact. And we also need to consider the proximity of the proposed receptors to the odour source, i.e. the composting facility, and the prevailing meteorological conditions, particularly wind speed and direction, to determine the likely frequency of impact and the effectiveness of that odour dispersion and dilution. Now, odour episodes tend to occur during stable atmospheric conditions with low wind speed, which gives poor dispersion and dilution. Receptors close to the source in all directions around it can be affected under these conditions. When conditions are not calm, it will be the downwind receptors that are affected. Overall, these receptors that are downwind with respect to the prevailing wind direction tend to be at higher risk of odour impact. And we found that during worst case conditions, so calm wind and the correct direction, would only occur around 5.34% of a 5-year average. We determined that the pathway effectiveness and the risk of odour impact was to be low due to the separation distance between the source and the receptors and the very limited duration of downwind weather conditions. So all signs so far tell us that odour should not be a significant constraint to development, but we can't ignore the extensive odour complaint history. We obtained complaints associated with Sutton Courtenay waste sites for a 5-year period. And while the sniff test considered the impacts of all waste sites to the east of the proposed development site, it was impossible to establish how many complaints were triggered by the composting facility. As you can see from the figure to the right, there are other waste sites around the area. Now, we found that 70% of all odour complaints were triggered by Sutton Courtenay waste sites, with many complainants living within Sutton Courtenay, where the proposed development site is. But when you look at the difference in populations, you can see why so many came from Sutton Courtenay as opposed to Appleford. There's a large difference in the population. In fact, the complaint numbers were higher between 2011 and 2014, reducing to an average of 55 per year in 2016 and 2022. And this likely reflects improved controls and mitigation measures, which have evolved over time. Now, the odour management plan had been developed and improved many times over the years, including improvements to things like odour controls and monitoring. And this video here, if you look closely, you will see a mist emerging. Well, this mist is actually an odour neutralizer. I remember when I said many of you will probably prefer the smell of bread to cow manure. Well, this is a great example of this concept at play. Because we can understand what generally constitutes as an unpleasant and a pleasant odour, measures like this can be implemented. But it should be noted that some people, like me not liking the smell of freshly baked bread, detest this odour. Again, it comes down to subjectivity. So how did we manage the complaints? So here you'll see an actual complaint made word for word. We went through each of these and we extracted key information. For example, the time the odour was detected, a rating, a potential loss of amenity, the weather conditions, and some idea as to the odour characteristics, or in other words, what it smelled like. And with the data extracted, you could start to see some patterns forming. People are describing the odour we would typically expect from a composting site. But I think what's interesting here are how the differences in scores are given. It really just shows the perception of odour varies between individuals. So we have our data, and it starts to get interesting when we start to look at the tools in combination, and we start to see a picture building. So here, met conditions are looked at in combination with the odour complaint history, and we start to see stark similarities. Worst case conditions occur on average approximately 5.34% of the year. Odour complaints were made from addresses in Sutton Courtenay at an average of 5.92% of the year. Even more striking is the fact that 98% of complainants from Sutton Courtenay occurred on days with an average daily wind speed of less than 2 miles per hour. And interestingly, and probably expectedly, when we look at the number of complaints in the max daily temperature, we found a correlation showing that more complaints were made in summer months over the winter months. So as a reminder, the original application was refused partly because of the lack of sufficient information to determine odour impacts for future residents. Therefore, we were instructed as part of the appeal process and carried out a qualitative odour assessment, utilising local metadata, historic complaint records, and sniff tests to consider the suitability of the proposed development site for residential use. Detailed review of prevailing Met conditions suggests that the site could only be downwind of the waste facilities or during calm conditions for very limited periods of the year. We found that evolving management improvements may have reduced the frequency and extent of complaints. The complaints occurred when these rare weather conditions coincided with the elevated odour emissions from the composting site, such as during the windrow's turn. Furthermore, the sniff test we completed demonstrated that even when weather conditions were conducive to causing odour impacts at representative locations within the proposed development site were negligible to slight adverse. And we considered that within this proof, combining all information available from the assessment tools, that there were no material reasons in relation to odour impact why the proposed residential development should not proceed. In accordance with the current IAQM guidance, we concluded that the overall odour impact at the proposed site was not significant. The inspector agreed that we provided sufficient information and acknowledges the subjectivity of odour. Remember, we're not trying to prove if odour is there or not. We're here to analyse and present the data to allow the inspector to determine if any detectable odour is acceptable for future residents. The inspector found that the proposals would result in limited harm to the health and well-being of future residents of the proposed development. The appeal was allowed and outline permission was granted for up to 175 dwellings and associated works. And this is the team that made it happen. If you have any questions after today that you don't manage to put down in the Q&A, please feel free to get in touch with any one of us. Thank you very much.
Right, thank you, Alicia, very interesting. And I think we are now moving to the second speaker, Patrick Harlan, Air Quality Consultant at Ricardo, who will be talking about the importance of olfactometry when assessing the impact of odor. Over to you, Patrick.
Thank you very much. I assume you can all see that. Someone could just let me know to make sure.
Good.
Yeah, perfect. Okay, good afternoon, everyone. My name is Patrick Harland. I'll introduce myself in a slide in a minute, but I'm going to be talking about the importance of olfactometry for assessing the impact of odour. So, in the talk, we are going to cover a few different areas, and we'll do a bit of a brief introduction into olfactometry and what it is. We'll discuss the circumstances of the case study that I'm going to be showing you, and then I'll be displaying the results from both the previous estimates that were made and then the results from the olfactometry that's been conducted since. So a bit of an introduction to who I am. I'm an air quality consultant at Ricardo. I've got a little bit of a lie on there, just under 3 years experience. I work in dispersion modelling, LAQM policy, nuisance complaints, odour sampling, odour management and odour modelling, and do quite a big range of different sites and different works. So having a look at olfactometry, there are a variety of techniques for analysing an air sample in regards to odour. This could be GCMS, electronic noses, sniff testing, as we've seen in the previous talk. However, the main one that we're set to look at today is olfactometry. So olfactometry is used to determine odour concentration, and it's completed using an odour sample taken on site. There's an image there of a sample being taken. I'll show a few more on the next slide. And the testing done with an olfactometer relies on diluting a sample to different levels, and in order to calculate, determining an odour threshold in order to calculate an odour concentration for the sample. So I'll go through the standards related to this in a couple of slides. But first, because who doesn't love a picture? We've got a few pictures of various different sites and a few different methods. So we've got a point source sample, an area source sample from compost sites, from sludge treatment bays, and then one for collecting a water sample to be used for odor potential. So these are quite typical of what would represent a typical site visit and the methods that we would use. Okay, so in terms of olfactometry, the olfactometry standard is the BSEN, or at least in the UK, it's the BSEN 13725, and it was updated in 2022. And it covers a pretty big range of different areas. It covers material to do with odor sampling, the olfactometer and sampling equipment and materials, your reference gases, so that's to do with your panel requirements, and also the lasting requirements as something's put through the olfactometer to make sure there's no sticky samples. But your reference gas is essentially when you're picking a panel, your panel have to be able to smell at a certain range. It also covers any dilution apparatus, the panel selection and requirements, quality assurance, and odor analysis. So olfactometry is used to work out an odor concentration. And calculating an odor concentration gives us a few options as to what we can do with it. It allows us to model the odor impact of a site, and this can be used to aid in any complaints analysis we may want to do and to corroborate any complaints or observations that have been made out in the field. You can also use it to develop management plans and assess any possible mitigation measures. So we have a picture here on the right that just shows an example of a model, and that was completed on a lagoon, and you can see from the odor emission rate various different levels at which the odor would be detected. Now, odor concentration, we would typically say that 3 odor units would be the point at which it's a noticeable and describable odor. So now moving to the example that I'm going to talk through. And we're looking at a dairy farm situated in the Middle East. And the image on the left shows the sort of scale of the farm. And this is approximately 1.5 kilometers across at its widest point. And on the right, we have a much closer up image to give a bit of a view as to the real surrounding area. And you can see how close we have some residential and commercial areas in relation to the farm. You have some that are sort of within 100 to 200 meters of some of your bedding areas. So looking at the site specifics, we have a range of different operations and potential sources. These are the bedding and paddock areas, the DAF plant, the SBR tanks, the composting OCU, the sludge storage, and the sludge drying. There are a couple more, but these are the main ones we focused on in terms of taking samples and producing an odor impact from them. So it should also be noted that there are some fairly specific factors relating to the site's location due to it being in the Middle East. There are things that are different to what would be normally experienced on a site in the UK. This is a higher average temperature, different humidity to UK conditions, a lack of drainage, and then rather crucially in this case, no land bank to absorb any potential. So all the pollution is kept on site. So in essence, in the UK, you would be more likely to see land spreading on farms and the removal of manure, whereas that would remain on site in this operation because there is no land or fields to spread the manure on. Looking at the site and the activity that there is going on, the site's got approximately 18,000 cows, and you'll note in the slide I've tried to get as many possible pictures of cows in there as possible. And there's over 60 paddocks or bedding areas, on-site milking sheds, on-site wastewater treatment, including on-site sludge management, and then on-site built biofilter operations. So now moving on to what estimates were made before any site work took place. We assessed the impact of the site based on a few assumptions, which we've got here on the slide. So that would be, these assumptions were made based on literature and the typical cow weight was assumed to be 550 kilograms, and there was a range of published odor emission factors of 6.8 to 396.6 odor units per second per cow. And in livestock units, this range equates to 5 to 310 odor units per second per livestock unit, with an average of 89 depending on the animal. For our initial study, we considered an odor emission rate of 100 odor units per second per cow to be considered a reasonable rate. And you can see from the model on the right here, those initial estimates showed a pretty significant impact. And essentially where we're looking is the sort of lime green is where you're starting to have a bit of an impact. And as you can see, it was modeled so much that it went outside the initial domain that was modeled. So it should be noted, there's a few specific issues for this site and others in the region. There is a lack of land availability, so there is encroachment on infrastructure, so dairy farms, sewage treatment plants, etc. Hence, this is the reason we've conducted the study, is to assess the impact now, looking as you have residential areas and commercial areas sort of encroaching on the existing infrastructure in place. So prior to our work completed, there was a study completed for the site in the past, and this focused on the existing scenarios and then any planned farm applications. And the study was completed focusing on hydrogen sulfide and ammonia as a target for how to develop the emissions. But it should be noted that odor is more complex than just hydrogen sulfide and ammonia, and that's why an issue was still deemed to be present. And the ammonia odor threshold is quite low in comparison to sort of the mix of compounds you would see inside it. So the emissions were based on chemical estimates from the manure of the cattle in this instance, and covered relatively different areas. The pictures on the slide aren't particularly clear to see, but the impact given there shows they're well within the sort of highways around it, and nowhere near as significant as the 100 odor units per second per cow that we were able to estimate. So before I go on to the olfactometer results, I thought it would be useful to have a quick note on the advantages and disadvantages of chemical analysis, although it should be said this slide could also refer to electronic noses, not just chemical analysis methods like GCMS or others. So in terms of advantages, they're qualitative, easily comparable. You've got emission limit values, so for things like H2S that you can compare against, and it gives a good understanding to the processes for those chemicals or for those compounds, which can reduce the impact, can be used to reduce the impact or produce mitigation. Disadvantages, on the other hand, are that the human nose is more sensitive than most sensors or analyzers, and odor can be a result of a complex mix of compounds. So you can end up, your sensors may pick up the specific compounds at various different concentrations. However, the impact from the odor could be from something entirely different. The detection of one chemical can lead to, in that instance, an underestimating of the impacts of others. Also, if done by sensors placed around a site, you may lose out on an estimate for how the odor has been dispersed, because all your sensors could be within the furthest extents, or they could all be upwind, downwind in the wrong place at the wrong time. And that's unless you've got a lot of them, and that's then looking at sort of more considerable expenses in terms of whether it's the site operator or yourselves. It should be noted, although this can apply to both, is that electronic noses do have the capacity to pick up everything, but they are nowhere near as sensitive as a human nose or GCMS, and often require recalibrating, and they need to be taught what odor they're looking for first. So they need to know what they're looking for before they're looking for it, which, if you've got a site with multiple different issues around, could pose a bit of a concern. So moving on to the results from the olfactometry, and just a bit of a clarify before I go through the rest of the results. it should be noted that this work is still ongoing, and so far we've conducted winter samples which were impacted by storms the week before we travelled out, and we will be conducting a further sampling campaign to get a better quality image and results to provide a better estimate. So the method to calculate the odour emission rate depended on the method employed to collect the sample. So you can see in the picture on the bottom right, we've got one with the Linval hood, which requires a different estimation method to just a point source sample that's maybe taken from an OCU stack or from a treatment plant, which relies on odour potential. So the eventual odour emission rate per animal was calculated to be 220 own units per second per cow. And you can see how that breaks down from the olfactometry in the table on the slide there, with the majority coming from the animal house as a total of all your bedding, feeding areas, and the like. So on this basis, the odour impact from the site may be up to 2.2 times higher than has been predicted in the example displayed earlier. So just as a bit of a clarifier, this model is a very rough estimation completed for the talk to compare to the earlier example, so can't be read into thoroughly and just serves as a bit of an indication as to how drastic the difference between the sensible estimations made originally and the actual sampled values can be. So we can see I've drastically increased the model domain and the scale of it, in which you're looking at some of the emissions at quite a high extent, going well over 10 kilometers. So comparing the two models, the olfactometry value was 2.2 times higher than the initial estimate. And I do apologise if they're not entirely clear here. As I said, the model only finished running this morning, and the images, they're quite wide, so you can't see as much detail. But if you use both the highways around the site and then the scale bars on the maps as reference, you can really see the significant difference in how far the odours are dispersing and travelling. And it must be said that the image on the right does show the absolute worst case scenario for the odour at this emission rate, so the worst hour of the year for odour emissions. So the outcomes from this so far, and as I said, this is still ongoing and there's more sampling to be conducted, but we have seen that the local regulator has already seen the benefit of using olfactometry, and they've introduced new requirements for all new applications to consider odour against odour benchmarks rather than just against the chemical analysis. And originally it was just H2S and ammonia. There's also been developed odour inventories in odour unit terms as opposed to the chemical concentration to allow for more complex sites with a more mixed emission of the compounds that are making up the odour. And then they've looked at developing controls using odour management planning procedures. So my role in this has been not only on site and going out there, but was also to develop an odour management system for use by the regulator, not too dissimilar to our own H4 odour document and the IAQM odour guidance for planning, which I believe was mentioned in the talk before. So I couldn't help but get one last picture of the cows in there. But that brings me to the end. Thank you very much for your time, and I hope you found it interesting. If you've got any questions, feel free to ask them in the Q&A bit or send me an email and I'll be more than happy to get back to you.
Thank you, Patrick. Yeah, there is already a question, but we will look at the question and answer later. Right, so now we are at the third presentation. This is from George Bracha, Senior Consultant at Air Quality Services, who will be talking about case study for the proposed Guinness Brewery in Covent Garden. Over to you, Patrick. Thank you.
Oh, Patrick, just a flag. I think you need to stop sharing your screen and then George can share his. Perfect.
Yeah, sorry, George. I was meaning about you.
That's okay, don't worry. That's fine. Sorry, be 1 moment. Can everyone see?
Oh no, you just need to press the green share screen button on Zoom first and then choose the window.
Oh, that's
Perfect. Thanks,
okay.
George.
That's great. I'll just move this over. Hello, everyone. My name is George Bratchell. I'm a senior consultant at Air Pollution Services and Odour Consultants. I have over 4 years experience in undertaking air quality and odour assessments throughout the UK. Today, I'm going to look at a qualitative assessment and odour mitigation measures in relation to a brewery case study. So the brewery in question is the proposed Guinness Brewery in central London. It's a unique project as it's the first brewery outside of Ireland which has been constructed. As the brewery is located in central London, it provides easy access to locals and tourists to enjoy the brewing process tour and also other amenities that this event will provide. However, issue with such a central location provides high sensitivity of receptors in local area. So we're going to look at that in further detail. So the development isn't just a brewery. It's also going to be a restaurant, as seen in the figure on the left of the screen, with a rooftop extension, which should provide 360 degrees around London. And then below there are also restaurants, kitchens, a bar and a shop, as seen on the ground floor. There will also be event space, which will provide food and drinks at certain times when the events are chosen to be used. The development is anticipated to finish construction later this year. I think it's been pushed back a few times due to construction restraints. To provide some context in relation to where the development is, as you can see in the figure, you have the Longacre Road. Just below that is Covent Garden Station, that building, which provides, again, easy access to the development. The brewery is located on 1 Mercer Walk, which is on the left-hand side of the figure. And Old Brewers Yard in the yellow is the event space. Shelton Street, just below that, in the red is where the restaurants, the kitchens, and the shop will be located. Neil Street is just a change of signage. Langley Street is just where the bins will be located, and the basement of Langley Street will provide a community space. The important parts are identifying the odour sources within the development. So the key odour sources we identified within the development were the kitchen extract systems, which come out of the building as seen in the figure in front of us, just at the front. Then the brewery will have a ventilation system and exhaust release flue, which is part of the brewery process. Also, odours may emanate from the brewing room. We also identified toilets and bin stalls. The toilets were discounted as insignificant source due to their inside nature, and the ventilations are part of them. And the bin stalls, as a team, were discussed, and it was agreed upon that the bins should have increased removal to decrease odour issues. The main point of this presentation is to focus on the kitchen extracts and the potential odours from the brewery. So first of all, we undertook an EMAC assessment for the kitchen extracts, and to understand whether they were suitable for their purpose and whether it meets the criteria set by the council. As many of you may know, there are a lot of ventilation notes or guidances provided by councils which need to be adhered to in the planning stage. When we were first assigned to the project, we were given the plans, and then we had meetings to provide input of the design of the development throughout the process. And one of the key elements was the kitchen extract system. It was just, we discussed with the team that it probably wasn't the right design, and further options were required. There's a really good diagram from London Borough Tower Hamlets, which provides a good overview of how kitchen extracts need to be considered. So we have the cooking area with letter A, then letter B represents the cook and hood, which most best practice is having 150 millimeter hangover over the cooking area. This allows the odors or the odorous air to be pushed up into the ventilation system. Letter C represents the grease filters. Letter D represents coarse pre-filters of usually 25 millimeters in depth. Letter E is fine pre-filter with a coarse level of 50 millimeters. And letter letter F is activated carbon filters, which are highly used for removing odors in ventilation systems. The letter G is the fan and motor to pull the air in. And then H and I are related to sound, as they are the anti-vibration mounting and noise attenuator. And then J represents the exhaust flue, which most councils require the flue exit to be 1 meter above the eaves of the building, 20 meters away from the nearest buildings, and exhaust velocities vary depending on the council. When we first joined the project, we were given the plans where the kitchen exhausts of 5 kitchens, which were all within the same building, was represented by the yellow dot. As seen in the top right figure, the exhaust was coming out horizontally and only 0.3 meters above the ground, above the eaves of the building. And just north of the yellow dot, the building above that in the figure, as shown, it is a residential property in areas and also offices, which provides a high level of exposure. And due to the windrows we looked at in the local area, the prevailing wind directions was southwesterly, which created an issue within the qualitative assessment. Therefore, working with the design team of the project, we provided a different exhaust flue location, which was just south of the previous one. And the main aspects were considering the council requirements for exhaust flues. And this includes having the exhaust flue finishing 1 meter above the eaves of the building. This increases dispersion as it's pointing upwards as well. So that vertical release almost pushes it into the atmosphere with greater aid for dispersion. The exhaust velocity at this stage was not changed. However, with further meetings with the council, this was later increased to 10 meters per second, which in combination with the vertical release aided in the dispersion of odors. Our assessment then concluded that in the qualitative assessment, that there would be no impact on the residential building north of the development. So now I'm going to talk about the brewing process and how we looked at potential mitigation methods with the project team. This, as due to the nature of this development, it's a highly sensitive area, and it's regarded as a highly valuable project to London due to tourism and the money it can bring into the local area. So therefore, it was the mitigation measures that were all mitigation measures were considered in this process. The process of brewing includes the mixing of malt, hops, and barley at 80 degrees, which is open to the atmosphere via pipes of air. The fermentation process is undertaken by the increase in temperature, which then starts to create the Guinness, which then leads to the release of CO2 in the process. This CO2 has the potential to be highly odorous, and was piped off into the system to be dealt with in the ventilation system. One of the key interesting parts about this project was the use of a scrubbing system for the odors. As you can see in the figure on the left, the fermentation CO2 was piped to a vapor condenser. The vapor condenser brought in the odorous air, and then a liquid was heated, which then condensed onto the top and fell down in the container as shown. What this does, this reacts with the odors to remove it and creates a separation of the liquids at the bottom, with highly odorous, it's highly odorous. The air is then released via the top, which then goes into the brewery ventilation extract. Within this ventilation extract, there was also the use of activated carbon filters. Activated carbon is used primarily in kitchen extracts, but in this instance, it was also used during the brewing ventilation extract to increase the quantity of odor removed before release. Activated carbon has a honeycomb-like structure, and this leads to increased surface area. Activated carbon reacts with odors to lead to absorption of the odors and remove them from the air. The other filters used within the system was also panel filters, back filters as well. We also advised to increase the absorption of activated carbon. It is recommended our residence time of 0.2 to 0.4 seconds. This is an increase on the usual recommended level of 0.1 seconds. This does provide a highly effective method to remove odor, as it's a combination of both aspects. During the process, it was discussed about the maintenance of the system. The extract system, the ventilation system is required to be cleaned every 6 to 12 months, and the activated carbon filters every 4 to 6 months. To discuss the last source, we looked at the potential for emanating odors from the brewery room. The brewery room could release odors via the exhaust flues or the ventilation system, or through doors and windows. To combat this issue in the local area, the project team discussed applying a negative pressure to the building. Most buildings in the UK are usually positive pressure, as they don't have ventilation systems. However, in this instance, a negative pressure system was put in place. And the diagram shows how this is done. There was vents put into within the building to pull the air out through the top, which then creates a suction where the positive air is pulled in through the doors and windows, creating also almost a vacuum-like suction from the vents. This air is then brought up into the ventilation extract and released. And the good part about this system is, even though the people are still experiencing the tours, they will still experience the Guinness smells and odours within the building. However, as they're getting released via the flues, they'll be cleaned by activated carbon filters and other filters like. This reduces the exposure on the outside of the buildings, but inside you still have the authentic experience for the future users. Thank you all for listening. If you have any questions, please let me know. My email as well. Thanks.
Thank you, George. Thank you. Right, I'm just conscious about the time. Our question and answer session now has been slightly reduced, so I'm just going to pick up the first question that was put in the chat. And if there are other questions, please carry on. Just put in the chat, and we can send a response later on. The question is for Patrick from Paul Otley. What percentile model outputs were produced for the FAR model? And was there a specific impact criteria that the local authority wanted you to use?
Yeah, hi Paul. So for the initial estimate, the example shown on the slides, the initial estimate of 100 only units was the 100th percentile in terms of the example on the slide, and then the later one was 98th percentile. It was assessed for 98th percentile both times. I just didn't have the image of the first one to hand. In terms of the study done by the site itself, I can't speak on that. I don't know, I'm afraid. In terms of specific impact criteria, we are looking at demonstrating the advantages of olfactometry in the area and against chemical analysis. So again, it was more looking at what impact was there at all, rather than a specific criteria we're up against. It should be noted, it was I believe the first time that olfactometry has been done out on site in that area, and it was more showing it can be done more than anything else. Yeah, I hope that answers your question.
Good. Well, I think we are just on time for the other question at this point, and we can just then crack on with the last presentation. So it's still another one for you, Patrick.
Mm-hmm.
And how did you assess your panelist odor sensitivity for the olfactometry? If you can keep a short answer, and then we move on. Thank you.
Yeah, so panelists are assessed by testing called acuity testing, and this is essentially you check a panelist's ability to smell an odor in their individual threshold estimates against butanol. So you're aiming between 20 to 80 ppb of butanol, and that is essentially, you get 12 estimates, and panelists have to fall within a certain standard deviation at a certain level that they can smell it. You're aiming for about 60 ppb. Yeah, that's it.
Super.
Feel free to email me for more detail on that.
Thank you. Right, I think it's now time to move to the final presentation. I'm delighted to introduce Lawrence Kerr for our final presentation on the updated IAQM odor guidance. Lawrence is a technical director at the Air Quality Consultant with 18 years experience in the field of air quality, odor, and climate change assessment and management. Lawrence was a member of the working group which developed the original IAQM odor guidance for plan in 2014 and is now the co-chair for the working group doing the current update. It's over to you now, Lawrence. Thank you.
Thank you, Davide. Good afternoon, everyone. Let me just share my screen. If you're all seeing that all right.
Yeah.
Thank you for the introduction. As David explained, I'm Lawrence Caird. I'm a technical director at AQC. I've been rattling around in the world of consultancy for about 20 years. What I'm talking to you about this afternoon is some updates that are currently in flight on the IAQM's guidance on the assessment of odours for planning. Bear with me. Now, from the perspective of this, I want to focus on the updates because there's only a sort of limited time, but I am conscious that there's probably a range of experience on this call, from those that know the guidance well and have used it a lot to those that maybe haven't used it at all before. So I'll start off with a very brief introduction about the guidance itself, when and where it was developed, and what it contains. Some of the previous speakers already helpfully given some insights to that anyway, and then talk about some of the key updates that will be released this year, in particular updates to source pathway receptor approach, sniff testing approach, guidance on odour modelling, guidance on case law and use of it, and other minor changes. Big fat disclaimer I think here is that at present the working group are finalising this guidance for updates. So at that point it's going to go through, be passed on to the IAQM committee. It may well go through consultation as well. And so I'll talk generally about the changes that are proposed as it currently stands, but there may be some changes to that between now and its final publication in the coming weeks and months. So to start with a brief introduction to the IAQM Odour guidance, what it is and what it's for. The guidance was originally developed in 2014 and was later updated had a minor update in 2020. At the time, the IAQM had identified that there was a bit of a guidance gap with respect to odours and odour assessment, whereby specific to the planning realm, really, where there was a huge wealth of existing odour guidance out there, but it was almost entirely aimed either at regulators or at operators of specific odorous processes. So, for example, the Environment Agency's H4 guidance, DEFRA had guidance for local authorities as a regulator of odorous processes, which has since been removed or redacted. SEPA, Scottish Environmental Protection Agency, have similar regulatory guidance. And then there's guidance documents, the DEFRA guidance on control of commercial odours from commercial kitchens, which George referenced, which DEFRA has closed down that one as well, but EMAC has picked that one up and republished it for practitioners to use. And DEFRA's Code of Practice for odours from sewage works is another example. So there's lots of good guidance out there, nothing specific for the planning regime. And the important difference to the planning regime was there's a lot more appetite to assess odorous processes that don't currently exist, and B, define an impact and effect, which none of these sort of guidance documents really helped with that much. So a working group was set up, guidance was developed, published in 2014, and updated in a few small ways in 2018. What the guidance has within it is it's got examples and guidance on a range of assessment tools, both predictive and observational. It's quite strong on the guidance that, due to the subjective nature of odours, that Alicia particularly honed in on, that multi-tool assessment approaches are very strongly recommended. There's huge sort of pros and cons and uncertainties around each individual methodology, and therefore applying multiple tools to reach a robust outcome is an important part of it. Things that are a bit unique to it, it has a source pathway receptor assessment approach for odour sources in general. There's a similar approach for commercial kitchens in the EMAC guidance, but there's not so much this sort of simplistic desk-based or screening type assessment procedure in other guidance documents. It has guidance on modelling and other methodology, on other methods, and some specific sniff test procedure, which kind of takes guidance that already existed, for example, in H4, develops it a little bit further to again help deliver you to a judgment about what scale and impact or effect is. Guidance was always intended to be used primarily for planning applications, although it can be applied in other circumstances as well. A lot of the guidance is very consistent with other guidance that's out there. And in doing that, one of the key aims of the guidance was to help practitioners determine impacts and effects in a way that is aligned with formal environmental assessment procedures like environmental impact assessment. So moving on to the 2024 working group and the 2024 updates. I'm just going to go through some of these key updates one at a time, just explain very quickly why the working group decided it required some changes, and broadly speaking, what the changes are. The whole documents get a bit of a refresh with a whole series of sort of minor wording updates and changes, but those are less substantial. So I'll just hone in on the more substantive changes. There's been quite a lot of change. I say quite a lot of change. Some new content to the source pathway receptor approach, which was sat within Appendix 1 of the existing guidance document. Why change it? Well, there was a number of reasons fed in from the working group, but two key ones really were examples where it had been seen that guidance within it, particularly worked examples that were sat within the existing guidance, were sort of used as judgments to kind of justify a particular conclusion around an odour assessment for another source in a very sort of narrow way, which was never what they were intended, how it was intended to be used. And secondly, limitations with the impact assessment matrix for the SBR assessments, specifically around the fact that if you have a small odour source, you can't have anything worse than a slight adverse effect. Whereas in practice, to give one example that aligns well with George's presentation, a commercial kitchen, it's hard to justify if it's just a small commercial kitchen that the odour source itself isn't small. However, if the discharge from the extraction system, for example, is at low level and immediately adjacent to a window that represents a sensitive receptor or a residential dwelling, for example, then it could absolutely be a significant effect on that property. So those are two reasons why we looked at doing changes. The changes that have therefore been made is Table 9, which was sort of general guidance on and kind of worked examples on defining the source odour potential and pathway effectiveness has been updated. Talk about that in a bit more detail in a second. Similarly, the impact matrix at Table 10 has been updated. And there's some further updates to the worked examples to fit in with the new process. We've also removed the guidance on receptors from that section as it overlapped with content in section 3 anyway. So a little bit more detail on the sort of the Table 9 point. The existing guidance, shall we say, is on the left, and the updated or the working draft updated version on the right. Table 9 is kind of split in two. There's at the very top row of Table 9, there's some factors, sort of a high level things that you should consider when defining source odour potential, pathway effectiveness, receptor sensitivity. And then below that, there were some examples, and this is where we see things maybe being a bit misused, we would say. So, for example, in the bottom table, bottom left there, it talks about a large source odour potential and defining unpleasantness processes classed as most offensive odours. Now we see examples where that has been used counterfactually to say if the odour isn't something that's most offensive, it can't be a large odour source, which is absolutely not the case. So what we really wanted to do is focus a bit more on the top row of Table 9 and say, if you're going to do an SPR assessment robustly, you need to consider all of these factors, evidence them, and provide real sort of weighted judgment about how you've landed with a particular judgment on a source odor potential or a pathway effectiveness. And that's what the updated table to the right hand side sort of shows. It's more providing a bit more steer on how you might consider some individual factors within the judgment. The one on the right shows source odor potential, but there's also one for the pathway effectiveness, and how you can stitch things together to lead you to a judgment about where a particular odor source or the pathway between that source and the receptor sits. The changes to the impact matrix are a bit more simple. It's basically been expanded from a 3x3 grid matrix to a 4x4 matrix. So we've added an additional pathway effectiveness, an extremely effective pathway to be used to describe receptors that are very, very proximal to the odor source, and also added a very large source odor potential, sort of stretching the number of brackets that you can group your odor source into, which allows a bit wider flexibility in terms of the outcomes from the assessment. There's also further guidance on applying it, justifying it, and when really the SPR assessment is best used as a screening assessment, a supplementary assessment tool, or a preliminary assessment tool, rather than something that's should really be used as just the sole assessment tool. However, we appreciate there's occasions where that might be appropriate. Sniff testing procedure has been updated. Why did we change that? There's some issues raised from the working group about incorrect application of the VDI odor intensity scale and how that affects your output results. And the current matrix or assessment matrices sort of were set up such that persistent distinctive odors, so odors that would be classified 3 on the VDI intensity scale, would often get the same level of impact as ones that weren't as strong as or were more imperceptible than that. So level 0 to 2, if stronger odors weren't present, because there was this cutoff for sort of the impact assessment at level VDI 4 and above. So what's been done, change the descriptions of the VDI intensity scale. It's still being used. It's just some of the guidance around it's been changed to help practitioners interpret it more clearly. We've updated the impact matrix in table 15 in the guidance, and provided some additional guidance on things to consider in sniff testing, which is helping determine factors like how many sniff tests should be required, what weather conditions to go out in, when and where to do the tests, things that Alicia sort of explained, where, you know, the appropriateness of being able to go to a location that's downwind on a particular day that's maybe not the precise receptor location, that sort of thing. On the VDI scale point, so really the way that the VDI scale should be applied, albeit certainly the way that the impact assessment process within the IAQM guidance would like it to be or intends it to be applied, is if you can describe the odor, that smells like bread, that smells like sewage, that smells like a cattle, then it's at least VDI 3. We do see reports where odors are quite precisely defined, but you don't get any intensity of higher than a 2. It was a faint sewage odor. It's a 2. Well, technically, if you're very confident that it's a sewage odor, it's recognizable, and therefore it should be a level 3 really. So we've essentially just provided updated descriptions of the VDI scale that's shown in the bottom right here, which just makes it a bit more transparent that I mean, essentially 0 to 2 is pretty subjective and is relatively little difference between them, but 3 is where the action starts in terms of you being able to determine the character of an odor, and be confident that what you're smelling is the odor source that you're assessing, or not the odor source that you're assessing, depending on what you experience. Updates to the matrix. Again, these focus around now, instead of applying weight to this concept of percentage odor time that's described across in the columns of the matrix, which is time at which the assessor experienced odors of intensity level 4 and above. That's been adjusted to intensity level 3 and above, mainly to give those occasions where you have, say, consistent faint odor that's hitting 3 every time, is going to hit a slightly higher impact level than it would currently do under the guidance as it's written now. This is something that's still probably the part that's still undergoing the most testing and finalization before the document's complete. So what you see here is maybe subject to some changes. Moving on to the odor modeling guidance. This is relatively straightforward. Why have we changed it? Well, IAQM are developing general dispersion modeling and guidance, which will include a section on odors. Therefore, odor modeling guidance within Appendix 1 in the IAQM guidance is just being removed so that it doesn't duplicate with or contradict anything that's in the IAQM dispersion modeling guidance that's being currently worked on. I think we're hoping that both guidance documents will be published around the same time, so there's not going to be a period of time with the guidance missing from the odor document without the backup of the IAQM modeling guidance alongside it. Case law appendix, which was Appendix 3 in the document. Why change this? Let's say what is it as well. So it was some previous case examples when it was described as case law, but it wasn't just legal cases. It was some examples of planning, inquiry type planning appeal decisions. It originally went in to provide some sort of guidance and support for evidencing certain judgments in odor assessments rather. However, I think with general consensus of the working group that any reference to case examples, be that planning appeals or legal cases, should be used very cautiously. That's twofold reasons really. One is things can get outdated quite quickly. Assessment practices change. Decisions of the past don't necessarily represent the status quo today. But also, particularly in the planning realm, there's a lot of judgments that demonstrate quite poor interpretation of the odor information that was in front of the inspector or inspectors at the time. And therefore, in that sort of inquiry environment, the decision of the inspector is only going to be as robust as the level of understanding the inspector got, which behind it is due to the quality of the odor witnesses and the quality of the odor evidence. So we've basically just decided to chop that out because we don't feel as a working group that actually publishing any case law or examples within a guidance document is appropriate anymore. So that will be removed from the final document. Last slide for me. Insofar as what else is changing, lots but not a lot. Lots of little minor changes to wording, some removal of outdated excerpts of text, a lot of tidying up where typos or grammatical errors were made, etc. And the only other potentially larger changes will be a potential consolidation of impact and effect matrices in section 3. So currently we have one in section 3. We then have a repeated version of it in section 5 to help specifically with dispersion modeling, is then repeated again in the SBR assessment and the sniff test assessment. Realistically, all of those broadly line up with very slightly, they're either identical or they have slightly different nomenclature in the tables, but they're intended to be as consistent as possible. So we're working to streamline those to a single sort of impact matrix, albeit that there's likely to be individual ones for different scales of offensiveness or categories for Odour, which currently exist with the matrices as they are presented for dispersion model outputs. Thank you, and that's everything from me. Happy to take any questions.
Thank you, Lawrence. Yeah, we got a couple of questions on the question and answer. One is from Natalie Espelid. When can we expect the updated guidance to be published? I was expecting this question.
Yeah, so it'll be finalised within the next couple of weeks from the point of view of the working committee. It then goes back to the IAQM committee to review it in the first instance. And my understanding, Ethne might be able to talk more about this, but there'll be then a view as to whether that goes out to member consultation or not. And if it does, it'll be a slightly longer period before it's finally published, because it'll go through that consultation first, albeit members will get to see it at that point anyway. So fairly soon, in the next month or so, I would expect.
Yeah, thanks, Lawrence. The next one was kind of similar, because it's asking, an anonymous asking, what is the rough timeline for publication of the new documents, the dispersion modeling and the other? You already mentioned about the other one, but is it Anthony? Have you got any?
Yeah.
Or you, maybe Lawrence as well.
Yeah, I don't have. I'd
No.
invite anyone that's on the call that's on that working group if there is someone to chip in, but I have no idea.
I'm not on that one, but there is another question, and I might add a little bit more on the last question, and then we can probably wrap up our webinar. Are there any regulators like Environment Agency or local authorities on the working group? And then I would like to add on this question as well. I say, how it has been successful? How many were working along the side with you? And it's always open as well for the early career members. Thank you.
Yeah. So it's simple answer to the direct question is no. We've had no participation from any officers within the EA or local authority officers this time. I wasn't party to the formation of the working group, so I don't know the process that went through. But we had about 12 on the working group. Everybody has come to the working group because they had some suggested changes. So every one of the dozen members have seen their thoughts and opinions taken into account and been offered the opportunity to review the changes. And it's probably been a subset of about 5 of us that have actually done the majority of those changes. So 12 on the working group, 12 voices heard, 5 doing writing, all 12 doing reviewing and edits, comments, suggestions, etc.
Perfect. Thank you, Lawrence. I can see Patrick Harlan has the hand up. He might want to add a question.
Yeah, sorry,
Yeah.
it wouldn't let me add a question to the Q&A box. I think
Yeah,
probably
feel
someone
free.
as presenter. I just wanted to ask what sort of overlap there was with the H4 guidance document and sort of how that's been considered.
So nothing's really changed in that respect. So that was all very considered quite carefully when the guidance was originally drafted in 2014. There hasn't been that many substantive changes to H4 in that time either. And it's mainly aligns with the sniff testing procedures are subtly different, but they're not materially different. Like you wouldn't conduct sniff testing following IAQM and it step on the toes of H4 or not be in line with the guidance that's within H4 in that respect. The main things was relating to the dispersion modeling element of things and Odour benchmarks, which we essentially, the IAQM guidance reproduces what's in H4 in terms of examples of most offensive, moderately offensive, and less offensive odours, and the 98th percentile impact benchmarks for them. And then the matrices that then take you from a moderately offensive odour threshold, 98th percentile threshold of 3 odour units, for example, to is that slight adverse, moderate adverse, substantial adverse. Yeah, those were developed and are unique to the IAQM guidance, but they are entirely consistent with that sort of quite hard, it's acceptable or it's unacceptable line that the H4 guidance draws with those benchmarks.
Yeah, okay, thank you.
Okay.
Right, Lawrence, I think we are at the closure time. I just would like to say thanks to all our speakers today. I think it's been really an interesting webinar. I hope so for you too. And yeah, just a couple of, I call housekeeping, or thank you for logging in and for attending. I hope that's been beneficial for you, all this information. And you can still record your attendance at this webinar in the IES CPD tool. So if you're interested to get your CPD, just log in into the member areas and you can record your CPD and download your certificate. This webinar has been recorded, as Ethel mentioned at the start, and we will be made available on our YouTube channel. If you are watching the recording on YouTube, please subscribe to our channel, like the video, and hit the bell to gain notification of new content. If you are interested in finding out more about how you can get involved on the IAQM Early Career Network, you can get in touch with myself, with Ethne, with Honor, and if you know anyone already on the subcommittee, you can go directly to them. We're always looking for more members to be involved on the newsletter. If you have any great topic you would like to share, and that's it from me. I would just say thank you to everybody again for attending the webinar, and see you next time.
Thank you, everyone. Thanks. Bye.